This is an example of an equation on a ramp where we have a mass of 10 kilograms, therefore of a weight of 98 newtons. It's resting on a ramp that has friction. Friction will oppose the direction of the falling mass. And there's a normal force. Those are the only three forces: the weight, the normal force, and the friction. So how do we address these problems? First things first, let's draw our axis like this. The x is actually positive going down the hill. It helps usually to put a positive direction in the direction of motion. And the y direction is upwards, which is perpendicular to the surface. So I've taken the x and y axis and kind of moved it around a little for convenience. That will make this problem simpler. Secondly, we realize that the w is off axis, and it's going to have a component that pushes into the ramp and then a component that pulls the mass down the ramp. So let's add those here. So w in the y direction is there, and w in the x direction is here. And by using those, that gets rid of w. Okay, so how do we figure out how big all of these forces are? Well, first thing to know, and this is not obvious, but the first thing to know is that this angle in here is the same as theta. How do I know that? The base is perpendicular to the gravity, and the ramp is perpendicular to wy, the y-axis. So if there's an angle between the ramp and the base of 40 degrees, then this angle up here is 40 degrees also. Hopefully you see that. If you don't, just take it on, as a basis for fact. So in the y direction, we're going to add up all the forces and see what happens. And in this situation, the box, the mass, does not go up and down relative to the perpendicular to the ramp. So what are the forces there? It's N minus Wy equals 0 because there's no acceleration. So N equals Wy. And how do I find that? Well, from a trig, Wy is the adjacent, W is the hypotenuse, so therefore this is W cosine of that angle. Please take a moment to confirm that for yourself. And when I put those into the equation and figure out what the heck is going on, that equals 75 newtons. Okay. So the mass is being pulled into the ramp, perpendicular by Wy, and that's a force of 75 newtons. And then the ramp is pushing up on the mass 75 newtons with the normal force. So we have gravity, the component of gravity pushing in, and we have the normal force pushing out. This allows us then to figure out how big are the frictional forces. So Fs max, is the max available force, equals mu s times n. And that's 0.6 times 75 newtons, which is 45 newtons. So the maximum available static friction is 45 newtons. If the object's moving, then the kinetic friction is the kinetic coefficient times n equals 0.4 times 75. This turns out to be 30 newtons. Okay? So in the x direction, I'm going to do all my forces in the x direction. There may be acceleration, so I can't say that's 0. It might turn out to be, but I can't say that's 0. In the positive x direction, which is down the hill, we have Wx. In the negative direction, I have minus friction. Don't know which one yet. Times max. How big is Wx? Wx equals W sine theta, which is 40 degrees. If I calculate that out, that's 63 newtons. So in this situation, I have 63 newtons down the ramp. I have 30 newtons of kinetic friction up the ramp. That equals MA, which is 10 kilograms times M times A. If I solve for that acceleration in the x direction, we go down the ramp at 30 with a force of 33 newtons divided by 10 kilograms. Sorry, 33 newtons divided by 10 kilograms equals 3.3 meters per second squared.